Hello, everyone. On behalf of IBM Systems Magazine, I'd like to welcome you to our presentation. My name is Janine Donnelly. I am the Manager of Webinars for IBM Systems Magazine, and I will be the moderator for today's event. We will be holding a Q&A session at the end of the webinar. You may ask a question at any time during the event by entering it into the Q&A panel. If you experience technical difficulties during the webinar, please use the Q&A panel to alert us, and someone will assist you. You may download a PDF version of the slide deck by clicking on the drop-down menu labeled Event Resources. You'll find that on the left side of your screen, and you can download those right from the platform without being disconnected from the webinar. Today's webinar, Putting CICS on Your SIEM Dashboards, is sponsored by HostBridge Technology. Our featured speaker today is Russ Teubner. We're delighted to have Russ speaking to you today. He is CEO and co-founder of HostBridge Technology. And for over 4 decades, Russ has been solving difficult problems associated with integrating IBM mainframes with web, cloud, and mobile applications. He has a number of patents and innovations to his credit, including delivering JavaScript to the mainframe over 10 years ago. So without further ado, Russ, I will turn the presentation over to you.
Janine, thank you very much. It's a pleasure to have this opportunity, and to everyone on the webcast, thank you for taking time out of your day to spend a little bit of time with us exploring this idea of how we can put CICS on your SIEM dashboards, things like Splunk or Elastic. One of the things I want to do to start with is just give you a little bit of background. As Janine indicated, HostBridge Technology has been around since 2000, although I and our team go back long before that in the CICS and the mainframe space. At HostBridge, our passion is really helping organizations integrate their existing CICS applications with other types of applications or data assets across an API. We have certain things that kind of guide us. For example, we always want to make sure that we use the best possible technique in order to integrate with your legacy or existing CICS artifacts. That leads us to doing pioneering work in the area of making sure that we can integrate to terminal-oriented transactions without screen scraping. We're also an ardent believer in industry standards, whether it has to do with using data vocabularies like XML or JSON, more often used today, or pioneering the use of JavaScript on the mainframe as a process automation or orchestration technology. And we understand we work hard to understand what's important to our customers, and to the vast majority of them, they don't even want to contemplate changing one line of code on their existing mainframe applications. Those are some of the things that guide us each and every day. Our latest endeavor is really, that we're going to talk about today, is really about how can organizations really see and understand what's driving their mainframe workload. For example, using the product that we're going to be talking about today, a major auto insurer wanted to really understand in detail when a customer when a customer added an insurance policy, just adding a vehicle to an existing policy, whether they did that through a self-service portal or through an agent across the phone. They wanted to know exactly when a request came in through that route for that bit of work, they wanted to know what it cost them really to do that. Now, using the product that we're going to be talking about today, they were first able to tell that one policy request, in other words, that big unit of business that they wanted to do, add a vehicle to policy, spawned 7,000 DB2 calls inside of various CICS transactions. Furthermore, in looking at that through the data, we were able to surmise that those 7,000 DB2 calls spawned 14,000 TCP switches. And that's because it turned out the nature of their CICS vendor-supplied application. And then finally, we were able to do the math pretty directly and figure out that 28 million unnecessary instructions were being executed as a result of adding that one policy, that one vehicle to an existing policy. And so the data that we were able to gather using this product, sending it down to an SIEM platform like Splunk, and doing this analysis allowed them to target exactly what they needed to do with their CICS applications, and particularly the vendor-supplied applications, in eliminating or at least moving down all those unnecessary instructions caused by the TCP switches. That's just one example of what we've seen one customer do already. But to start with, we'd really like to hear from you just a little bit, and that will shape some of the comments that I make going forward. And so we have a very simple poll here, and the heart of this poll is really to pose the question to you: how difficult is it for you to stitch together and really know how distributed work presented to the mainframe via a distributed source like a web or cloud-based users or mobile-based activity? How difficult is it for you to know precisely how that activity is driving your CICS transaction workload? Janine, would you guide us through the process of responding to this poll?
Sure, Russ. So as many folks have already done, go ahead and select your answer. Hit submit. We will be sharing the results of the poll with you. The early results are pretty interesting, Russ.
Yeah, I was just looking at them.
Okay. Let's give it one more second here for a few more answers to come in. There we go. I'm going to go ahead and launch these results to the audience.
Okay.
All right.
Okay, so as we can see from the, let me get over to the surveys tab. As we can see, the big winners were very difficult and difficult. In fact, it looks like 88, almost 89% of the responding individuals have confirmed that this is difficult or very difficult. No one said very easy. Some were neutral on the matter. So I think we all agree, or can agree, seeing this, that there are challenges in doing this, and we hope that you find HTAC, the product that we'll be talking about today, as one solution to help you and your organization make this a lot easier. And that's really what we're going to talk about. So we call it the HostBridge Transaction Analytics Connector. It was somewhat challenging to come up with a title for this product, simply because what we need to do is describe something very precise. I'm going to walk through a series of slides in a minute that will tell you exactly where this component lives and what it does. But the bottom line is simple. This is a bit of software, a software product that we will provide, that we do provide, that allows you to correlate non-mainframe service requests to the actual work done inside of CICS to process those requests. And as you'll see in a few slides, this product works hand in glove with a relatively new feature of CICS called CICS Transaction Tracking. But before we get into that, let me just lay the foundation and the predicate for this product a bit more. All of us who are live in the IBM ZOS mainframe world, we live in a de facto hybrid IT environment. And by hybrid IT, we mean for sure that the mainframe is not the only actor. You know, maybe 3 decades ago it was, maybe even 2 for some organizations, but clearly, if you own and operate a mainframe today as part of your mission-critical infrastructure, you live in a hybrid world. Now, the hybrid world, though, the mainframe gets requests coming to it from many sides. In aggregate, what we see are a lot of requests coming to the mainframe for running CICS workload that come directly from individuals, direct host application users, the people kind of envisioned on the right of this diagram with those PC or workstation looking symbols. These are individuals who are maybe working at a PC or some sort of a device, and they are interacting directly with those applications, maybe across some sort of an emulator of some kind. Still, we see that a lot across the industry today. But on the left side, it's a little different. This is where all the growth has been. All sorts of requests coming into the mainframe from distributed users, whether they're across a cloud or a mobile platform. They're coming into middle-tier application servers, and then very specific requests for data and or business logic invocation are driven to the mainframe. Responses go out, UIs are created, and the user's request is satisfied. And so when we look at this idea of how do we track work, we kind of use this diagram to guide us. So for example, on the right side of the diagram, in the kind of historical model where users are directly interacting with applications on the mainframe, actually the data, the kind of the host performance data visibility is pretty good. You know, the SMF 110 records that get cut might have a terminal, a logical terminal ID of some kind. That logical terminal ID can be correlated back to a user, a group of users, a region, a country, something like that. And so you can at least get some sort of an indication about who or what is driving your workload. Similarly, when we look at the far left side of the diagram, where we're just concerned about the patterns of usage amongst the mobile or cloud-based users and middle-tier servers, there are a number of products on the market from various organizations that allow you to really kind of get a feel for what's going on there, allow you to track the data that, you know, a request that comes in from an iPhone app, and yes, it goes over to a middle-tier server and it runs this Java class and does this and does that. It can knit all that together. Where the problem comes in is really right there, and that is, what if those middle-tier servers are now driving work over to ZOS and specifically to CICS, and we now want to be able to figure out who or what is driving this workload? Where is it coming from? What are the activities that are occurring? Because sometimes all of these layers, they add value, but they do obscure many details, and they're about what's driving the workload. For example, it's not unusual to look at a collection of SMF 110 records from a day's operation of CICS, and it just looks like they all came from a middle-tier application server. Well, that doesn't tell us a whole lot as to the dynamics of our work. So this is the problem we're trying to solve. We're trying to solve or enhance the visibility, the end-to-end visibility between all the actors and players and components in the distributed world and the mainframe and the CICS transactions that are running on it. Now, I'm going to use this diagram, and I hope you can enlarge this on your screen to see it. This is a diagram that we're going to be adding to it a number of other visual elements, but it's all going to be predicated on this one diagram. Because what we've intended or tried to do here is capture the kind of the guts, the basic components that your network, your infrastructure is comprised of. So on the left-hand side, we have all of the end-user devices. Those devices are then connecting in typically to some sort of a non-mainframe application server or server farm. Various types of applications, you may own this on site, they may be cloud deployed, whatever. These devices are coming across some network into some sort of a non-mainframe application server environment. In that environment, if in fact either data and or business logic assets need to be accessed or invoked on a mainframe, there will be some sort of a communication pathway. Now, I've annotated 3 here, that being CTG, CICS Transaction Gateway, which we run into quite a bit, HTTP, direct HTTP connections, which we see more and more, direct socket-oriented connections, and yes, those still exist in some very high-volume CICS environments. Another environment that I just ran out of room to annotate was MQ, but MQ operationally, by the time it gets to the inside of CICS, looks a whole lot like the way CTG and or EXCI work. So I'll just ask you to use your imagination just a bit with that. And then once that request comes in, there's always a lead transaction, and that's the one that's kind of circled with a dotted gray line. But then that transaction, as a result of the normal CICS operation patterns, tends to spawn activities. So for example, if that transaction wants to execute another transaction, a child transaction, and maybe it's even in a different region, then that will be running in a separate region. And maybe there are mirror transactions that are created. And so you kind of have this cascading effect of transactions and or programs that are invoked within the CICS environment to respond to that single request coming in from a port of entry. So we're going to use this as our basic diagram and now begin to build to it. The first thing I want to do is clarify where HostBridge, the HTAC component, lives. And that is, it lives in the CICS region that is serving as what I would call the port of entry or the point of entry into your CICS plex or your collection of CICS regions that are serving the business requirement. We live there. We do not have to live in any of the AORs. We just live right there in the CICS region that serves as the point of entry. You may call it a TOR, a WR, whatever you call it. That's where this code lives. Now, it has one job, and that is to extract data, relevant information about the request, and cause it to be saved appropriately as origin data managed by CICS transaction tracking. So when I say that what host HTAC does is it extracts the data and then it annotates or adds to the origin data managed by transaction tracking. Now, of course, in saying that, I've begged a question. What is transaction tracking? CICS transaction tracking is a really great feature that began to be added in version 4 of CICS and then matured and really hit its stride in version 5. Now it's a wonderful capability. It's there waiting to be used. And we chose with our HTAC product to exploit transaction tracking. Now let me tell you exactly what transaction tracking is and isn't. Transaction tracking was kind of, to me, I can't speak for IBM, but it was really a response to clean up a bit of a mess. And the mess was very simple. It was that this need to track transactions or the dependencies, kind of the way the dominoes fall inside of various CICS regions, isn't new. It's been around for a long time. However, doing that was never really part of the infrastructure of CICS. So as a result, there was a vacuum and various independent software vendors built solutions to solve that problem. I'm aware of at least 3 that were developed over a long period of time. And all of these products, in my view, were rather invasive. In other words, for example, the one that we run across the most, actually in the real world environment, is SysView for CICS that comes from CA. Now, although SysView is first and foremost a kind of a performance monitoring tool or a tool to give you visibility to the activities inside of the CICS region, it can also do this sort of stitching together or annotation of transactions and figure out that A started B and B started C and C lived in a different region. But the price you pay for that is needing to install all sorts of CICS exits, whether they are glues or trues, as we call them, in every region. So as a result, if you want, it's a little invasive, and I think that product is great, but you just have to recognize that in order to use it, you do have to install it in every region, and that's a problem, especially for organizations who are trying to spin up more regions for testing or make their environment more agile. So what CICS did is they decided to create, or what IBM did, is they created the necessary infrastructure inside of CICS in order to keep track of that. Now their job is to create the infrastructure. So when that lead transaction comes in, the one in the circle, it is assigned what is called a transaction group identifier, or tran group ID. And we'll see an example of that in a minute. And then as a transaction starts another one, let's say A starts B and B starts C, that tran group ID and the origin data related to that original transaction is carried with all of the transactions, and it is annotated in the monitor record, which becomes the SMF data that's ultimately produced. So, saying nothing more than what I have on this slide, we now know that HTAC works hand in glove with CICS transaction tracking. We are not providing the value of transaction tracking, clearly. What we do is we leverage the power of that feature of CICS by adding to the origin data information from the outside world. Then we can actually stitch it all together using a product, using an SIEM product, something like Splunk. Okay, so let's go ahead, and now that we've kind of we've kind of worked through all the theory here, HTAC extracts the data, it annotates the necessary control blocks related to transaction tracking, then somehow that data, most likely in the form of an SMF 110 record, needs to be published. Likewise, data from the non-mainframe side is published. And as long as both of those sources of data about that activity have the same correlation data, then we can actually see end-to-end the pathway for how a given end user with a given function or requesting a given function propagated all the way through to the execution of a certain number of CICS transactions. We'll actually show that in a minute. So let's move on just a little bit more, and we won't belabor this, but the way that we go about extracting and obtaining the request correlation data that is added to the transaction tracking payload depends upon the transport. So for sockets, we might extract it from the inbound socket request. For HTTP, which is what we'll demonstrate in a minute, we will typically extract it from a header because HTTP has a built-in concept of out-of-band data or descriptive or metadata that is flowing with the request in the form of a set of HTTP headers. And in the world of HTTP today, if you actually were to look at most requests, there is typically some sort of a header that clearly annotates a bit of request ID information. Sometimes that request ID is generated all the way to the left side of the diagram by maybe a Cisco router or an F5 load balancer. That's not uncommon at all. And then that request ID flows into the non-mainframe app server. It can then use that data to produce all sorts of information down to an SIEM platform. But the problem we're trying to solve is we want that correlation data to flow all the way into the mainframe, and then we want that data to end up in an SMF 110 record or some other bit of information or data that can go down to an analytics platform so that we can stitch it all together. Now, I'll dwell on another point here just for a minute, and that is, okay, so how does this enriched transaction, this enriched data, get down to the mainframe or get down to a platform like Splunk? There are really two methodologies that we currently support. One, and I'll talk about each of them, one is built into HTAC, and we also support, in partnership with SyncSort, their product called IronStream. Now, the component that we deliver with HTAC, which we call the HTAC emitter, it runs under CICS. It'll fire up right out of the box, and it's great for POCs. It's also important to note how it's driven, and that is it's driven through a CICS exit in that one region, and it is the XMN OUT exit. That is the exit or the monitor exit to the monitor exit that will allow us to see the CICS monitor record before it is passed to SMF for processing and disposition. So as a result, we get it a little earlier because we're not subject to SMF buffering, and we're able to emit it directly. So it's a great solution for doing something very quick. In fact, we'll be in New York City next week installing this at a large organization up there. We'll drop this in, and the built-in emitter will come up and immediately begin pushing data out to their Splunk platform. The other option we support is SIGSORT IronStream. This is an MVS-based solution, so what I'm implying by that is it lives outside of CICS. It's great for highly scaled environments, and it's driven via an SMF exit. So whereas our built-in emitter is running in an individual CICS region, IronStream is running outside those regions and is gathering its data from SMF. So those are two ways that we support. And what we'll be doing today in this brief demo is I will be using the built-in emitter just because it's a little simpler for me to demonstrate given the time constraints that we have. Now, I'm going to switch screens in just a minute, but let me identify a couple of the components for the configuration. First, the SIEM platform that we're going to be using is Splunk, and so there will be a point in the demo where I'll flip over to the Splunk screen, and we'll do a couple of simple Splunk requests and do things. We're also going to be driving a couple of very simple CICS transactions to actually be the workload. And then to drive that activity, we're going to be using a tool called Postman to actually drive the work request in. And I'll kind of give you a bit of a guided tour of that. So let's go ahead and switch over to our live demo screen. So you should be seeing my screen come up. Right now, I think you see a big green screen. There is Splunk. And let's go over here. Okay. Now, just to get you oriented, this is intended to be the simplest of all possible demonstrations to be able to describe what, in fact, HTAC does. And so we're not trying to be, this is not the fanciest demonstration you're ever going to see, but I just want you to go away knowing this was real. This really was exactly what happened and how all these components work. So up here, you'll see an HTTP request, and we're going to send this request to HostBridge running on CICS. Now, before I go any further, let me just say that I'm sending this request to HostBridge just as a matter of convenience. HTAC does not require any other HostBridge component whatsoever. This can work exactly, so if you install HTAC, it doesn't matter if you have any other product that we provide or support, you'll be able to have it function exactly the way that you see this functioning today. Now, what I've done is I'm using Postman to actually specify certain headers in the HTTP request. One very common header that is used in the world for HTTP requests is a header by the name of x-request-id. There's another one that's very common called x-correlation ID. And if you were to do a Wireshark trace of a lot of the HTTP traffic flowing across your network, you would see these headers coming in from your HTTP clients and probably even on your server-to-server HTTP connections. So what we're going to do here is using Postman, we're going to send this request directly to HostBridge, which is running under CICS. And on this HTTP request, we're going to specify an HTTP header of that name and with the value of this is Russ on Wednesday. And then I'll come over here and I'll press the send key. And that will actually send that in, and then we'll get a response. So let's just go ahead and do that. Now, what it did under the covers, we'll see in a minute, but this XML document that you see down in the body is actually the response that was returned by HostBridge. Again, please don't focus on the fact that I'm sending the request in to our product, our HostBridge product running under CICS or our JavaScript engine, or the fact that it's bringing back XML. It could just as easily be JSON. It really doesn't matter. The point is that we sent in a request, and it had a particular header. We extracted that header, and now we expect to find information about this request living in Splunk. So let's just go ahead and get back to the Splunk main screen. Now, anyone who has been around Splunk for more than 10 seconds has seen this screen many, many times in their life. And I'm going to use this screen kind of as my starting point to run a search. And I'm going to enter the most, one of the simplest searches you could imagine. And that is, I'm just going to say I want to go to any index. I'm going to look at the top 6 records, and I'm going to take some of that information and format a very simple table. Okay, so there we have it. My data is there. And you'll notice that when I ran that request, let's see, it looks like 6 actual transactions ran underneath the covers of CICS, and it involved 2 different regions. Now, we will look at the details in a minute, and believe me, there are plenty of details. This is Splunk's representation of the actual detail sent down for each record. And as you can see, it is voluminous. And on the basis of this data, we can do all sorts of analysis, either about the transactions themselves, but also about the remote source, the remote user, or remote activity that caused this work to be performed. But let's go back over to the statistics panel and just look at what we have here. All I've done here is I've highlighted 4 columns besides start and stop. First is the Tran Group ID. Now, the fact that all of this work, which was spawned from a single HTTP request, the fact that it all has a common Tran Group ID, that is courtesy of CICS transaction tracking. That's what transaction tracking is all about. It's about making sure that each one of these related and dependent transactions are tagged with exactly the same group ID. And in fact, you can see what the GAPL ID is actually the region in which it ran, and Tran is the SMF110 nickname for the actual transaction that was run. As you can see, a number of transactions ran. Let me sort this by, I'll sort it by start time. And you can see that the lead transaction, of course, was CWXN. It then started HWBA, which ran HBGP in the local region, then causing a mirror transaction to be created in a remote region, CICS-C, causing HBGP to be run again, and ultimately the TRAD transaction. But please note that in all of those user transactions, the correlation data that we sent in on the X-request ID header is there. It's present. So the Tran Group ID is courtesy of CICS transaction tracking. But the OUser core, the correlation data, is from HTAC. In fact, if we look at the actual SMF110 records, we'll see a lot of fields that, in fact, begin with O. And the O, this is all the origin data. And here you can see that, in fact, the OUser core data was, this is Russ on Wednesday 2. We also see other things. The URL it came from, the client address that happens to be the address of my browser. We get lots of other data. So I don't want you to think at all that all you can do is create simple visualizations like this. This is just meant to prove what is the value that, A, the correlation was affected, what is the value of transaction tracking, and what is the value that HTAC is providing in bringing and extracting the user correlation data and associating it with a request. Now, you'll have to use your imagination a bit, but just imagine if now you have all of this data for every request down in Splunk, and you know exactly, or you have a far better picture of the end-to-end pathway. You know what caused this work to occur. Again, doing some pretty impressive things. And in fact, I'll terminate the screen share, and I'll go back to the slides, and I'll show you another slide. And I hope you can enlarge this just a little bit. This is a sample dashboard that was created at a live customer who uses this product. Now, their objective with this dashboard was to analyze the performance impact of a particular set of CICS workload being driven from a particular distributed system. Now, there's a lot of aggregation that's going on here, and I won't try to, the purpose of this is not to say that this chart represents the ultimate value proposition of what you can do with this product, but this solved a problem that they cared about. Now, so what we did here, we know that as part of the workload executed from this particular distributed system, it accounted for 1,726 transactions. They wanted to know lots of details about that workload. In other words, why was it taking longer? Why did it seem slow? What was going on with it? Well, since we had all of the SMF 110 data also down in Splunk, we could not only tie together this workload to the remote users and or activity that drove it, we can also actually analyze it to see what it costs and then look for areas of optimization. This particular dashboard guided us through the process to really be able to see that there were two things that certainly jumped out to me. One was the fact that this transaction workload executed 5.7 million CICS commands, a rather staggering number, and that the QRTCB dispatch delay percentage was bumping 50%. And then we also created a little diagram down at the bottom where you can see in a bar chart format exactly what was happening inside of CICS, what were those exec CICS requests that this remote workload was causing. That's just an idea. Again, I hope just seeing something like this allows your imagination to run wild a bit. Because now that we can tie together, now that we can tag CICS workload with something that tells us where it came from as a request correlation ID, and the fact that we can now drive that information related to CICS and the middle tier down to a common analytics platform, now we can begin to answer some real interesting questions. So we think HTAC is really ideal for those organizations who really want to answer those questions. What services are really being running? What's really happening? What are my end users doing? What's the relationship between end user behavior and activity and the internal CICS processing workload? How fast are they running? How much CPU are they using? And most importantly, where are the bottlenecks in the end-to-end configuration? I can't tell you how many times we've been in calls with customers where, because there is no instrumentation going on within the mainframe about these matters, or to state it differently, because the middle tier support professionals kind of view the mainframe as a black hole, it never fails that there's always kind of a finger pointing match where, and it really stems from one simple cause, and that is we don't have a common basis, a common analytics platform to be able to see, okay, this request really did go in to the mainframe, and the response really did come out, let's say 20 milliseconds later. Well, that's not the bottleneck then. Maybe there's another bottleneck somewhere else. So we believe that being able to create this sort of visibility has some significant operational benefits for organizations, but also allows them to, by seeing those relationships, tune their CICS environment to be more optimal. And in the case of the customer that I referenced earlier, they've already begun using this to drive more and more workload through their existing CICS and mainframe footprint. Okay, with all that as background, Janine, I think it's time for me to stop talking and us to take some questions.
All right, great, Russ. First question, what SIEM platforms does HTAC support?
Good question. Notwithstanding the fact that I have demonstrated all this using Splunk, it's really it's not intended to be Splunk specific. We focused on Splunk just because when we surveyed a handful of customers, they all had Splunk, and so it seemed to be a reasonable starting point. But we have other customers who are interested in platforms like Elastic. And there are some other ones even beyond that. The ones we find most in our customer base are Splunk first, Elastic second, and yes, we support them both. Because again, what we are doing is ensuring that this request correlation data is added to, or is caused to be added to the data that CICS ultimately produces for a transaction. And so any mechanism that a customer can cook up for getting that SMF data down to an analytics platform that they prefer. Maybe it's not Splunk, maybe it's not Elastic, maybe it's even something they wrote themselves over the past decade or so. We really don't care about that. So the answer is we support any analytics platform in exactly what the functionality we're providing. Our emitter today emits a JSON document, and so that too is somewhat, we're kind of agnostic. As long as the analytics platform can process that JSON document, that's great. So good question, good answer. I hope it's a good answer in the sense that we really don't have any bias, and you can use whatever analytics platform you want, even one you created yourself.
Perfect. And Russ, I'm going to go ahead and put up this next slide with for folks in case they want more information. They can jot this stuff down as we continue on with Q&A.
Yeah, go ahead.
All right. How much does HTAC cost, and how is it licensed?
Good question. First of all, an initial license of HTAC is free, and as long as your transaction volume doesn't go too high, we've a respectable amount of volume in a proof of concept region or a test region. It's actually free and there's no cost. So low volume costs nothing. After that, the cost varies strictly with volume, but we've tried to make it very, very reasonable. I would just ask that you maybe contact us, either myself or someone on our team, and we'll be glad to provide you with detailed cost information and give you a complete estimate. We've tried to price it based upon volume. In other words, if we achieve a correlation, if we extract data coming out of a request and get it over into as part of the correlation data, if we do our thing, that adds value. So if let's say you run 100 million transactions a day, or 100 million requests are coming in, and you're only going to use our product to be able to analyze and extract data or correlation data from 10 million of those requests, then you would only be on the 10 million kind of price chart.
Got it.
So we try to do it just based upon your actual usage of the product.
All right.
I also saw another question here that it's really a great question. It made the observation that CICS is at the tail end of a much larger message flow. Boy, is that true. And it might start potentially at a home internet user or a mobile user. Do you have a way to tie correlation data that starts in a distributed system so we can see the full picture? Well, that's exactly what we wanted to do. That's exactly what this product does. We want to, so imagine when I was showing that Postman screen and I was sending in that initial HTTP request, imagine that request went to an intermediate server, and now that intermediate server might forward it to a second server, and then ultimately it goes to the CICS, to the mainframe running CICS. As you said, CICS being the tail end of a much larger flow. As long as that point of contact interacting with CICS can put something in the request flow, in a channel, in a container, in a COM area, in a request header, in an MQ message, as long as they can get it somewhere in that, then we'll extract that correlation data, we will enrich the transaction tracking origin data, and it will come out. Now, there are certain scenarios where it's just impossible for your client device or app running on an iPhone to be able to get their a common set of correlation data all the way through to CICS running on the mainframe. It's just too hard or logistically impossible. Again, all you need to do, since you have the power of an analytics platform like Splunk or Elastic, all you have to do, as long as you can correlate point A to B and then B to C and C to D, let's imagine that CICS is D, then as long as I have correlation data annotating all of those legs, then yes, I can easily merge them together and see a composite view. So yes, this question, that's exactly what this product is intended for. It's intended to be a targeted strike at making sure that that last mile, and that when I say the last mile, that leg into the mainframe is correctly annotated with some request data so that then when all of the information about the request flow in full gets down to the analytics platform, you can piece it all together. I see another question here. Do you have to modify any application code in order to use HTAC and a Splunk solution? The answer is absolutely not. You don't need to modify it. We run completely out of band. So when we do that extraction work, whether it's coming in across HTTP or CTG or sockets, there's no need to modify the app. Now, there are certain situations, for example, where you might have a requirement. Let me back up. There are certain situations that I can envision a customer calling us and saying, hey, we have a bit of correlation data inside our app that we would like to add through your product to the origin data. We've already encountered that once. And my answer was great. Then why don't we give you some sort of a programmatic call that you can make? Think of it kind of as an exit of sorts, that your program can just make a call and your application can actually enrich the origin data directly. I can envision scenarios like that. So if a customer wishes to modify an app to play a game in the enrichment process, fine. But out of the box, absolutely not. Don't have to make the application. Don't have to make any changes.
Oh, sorry,
yeah.
I hate to interrupt, but before folks have to perhaps exit the webinar to get to their next meeting and stuff, we'll come back to Q&A, but do you want to talk? I just saw the reference here to trying HTAC for free. Do you want to touch on that before folks take off?
Oh, sure. Just send us an email to, you can send it to info@hostbridge.com, which is on your screen. By the way, my email address is simply russ@hostbridge.com. Feel free to communicate with me. Call us. Go to our website. You can chat with us online. All you have to do is make the request. We'll make the download available to you, and you'll be off and running. And anything we can do to help you, we'll be happy to do.
Thanks, Russ. How about this one? Does HTAC have any other HostBridge software as a prerequisite? So do I have to have some of your other products?
No, absolutely not. There's absolutely no requirement that you have our JavaScript engine running under CICS or any other product from HostBridge. HTAC is a completely standalone product. We want it to be of value to any organization, regardless of what your integration approach, technique, technology, or application environment is.
Okay. I don't know if you want to take that next one without mentioning a product name, or just talk about perhaps how your product is different from.
Yeah, just we have a question here about how HTAC compares to another product that is also kind of in the end-to-end response time analytics world. Probably shouldn't mention too many product names. there are products out there that focus on end-to-end response time. The problem, however, is that their granularity on the mainframe seems to break down quickly. In other words, it's easy for these products to say, okay, I sent an HTTP request into the mainframe and I got a response, let's say 500 milliseconds later, and then add that into the overall kind of response time grid that they're presenting to the customer. So if your organization is happy with just kind of seeing the mainframe kind of as a big black box on the diagram, that's fine. We want to go far deeper than that. We are not, our customers, or we envision people who are interested in HTAC as not being content with just thinking of the mainframe as one thing that gets a request and then responds in a given number of milliseconds. They want to know what's really happening. They want to track end to end, not just from the end user to the mainframe, but all the way to the actual workload, the transactional elements that were executed, and what the performance impact of those transactions were stemming from that activity. So the difference really is what we're trying to do with HTAC is provide you with the necessary and sufficient capabilities so that you can have a far higher resolution microscope through a platform like Splunk or Elastic for being able to analyze your real, true end-to-end request response flows.
Great, thanks. Russ, can you answer this one? What versions of CICS does HTAC support? Don't know if you know that off the top of your head.
Yeah. Technically, CICS transaction tracking first started being introduced in about CICS 4.2. So I guess my technical answer would be 4.2. It'd be one of two things. Either 4.2 would be the first version that we would support, or the oldest version that we would support. Our second answer would be we'll support any version of CICS that IBM supports. Now today we're living in a 5.4 world, and in fact my recommendation to customers would be there was between 4.2 and 5, IBM, this transaction tracking component of CICS kind of grew up a little bit more. Some new fields were added as part of the origin data, and they're really cool. And so I encourage people to always be on CICS version, some version of CICS version 5. But technically, you could go all the way back to a later version of 4, and we'd be fine.
Great. Well, seeing no more questions, I do want to thank everybody for attending, but even more importantly, participating today. Thank you so much for your questions. It adds so much value. We appreciate it. And I want to thank you, Russ, for sharing your expertise with us today. Just a reminder that later this week, watch for a follow-up email. It will contain a link to the recording of today's webinar. That concludes our webinar. Thanks again, and have a great day.